There we go. Now we're recording. All right. So section 2.3, we want to determine whether this is a function or not. This is like deja vu for some of you. The other ones have just woke up. They're saying, wow, this is new. Y equals 2x plus 3 is a linear equation. And if I write y equals 2x plus 3 this way, this is called a linear function. A function is a special equation. These two are the same. We just write y when we have linear equation, and we write f parentheses x when we have a linear function. Y equals f parentheses x. They're the same thing. We can call them both y. One is just, we call it a function. The other one's an equation. Functions have special situations. Like in this first problem, determine whether this is a function. If we have a repeating x, let's do the one that down here. These are two repeating x values. These are coordinates, xy, xy. xy. We have two repeating x's. A function cannot have a repeating x value. Here we have a repeating x value. So b is not a function. A has all different x values. So yes, this is a function. Okay, so repeating x values mean if you have a repeating x value, it is not a function. This one here, these are just another way of showing the x values and the y values. If I do the x value of 4, this goes to a y value of 13. If I go to the x value of 7, this goes to a y value of 8. If I have an x value of 12, this goes to a y value of 5. And also, if you go to 12, it also has a y value of 8. In this one, we have a repeating x. So no, not a function. And if we do part B and write them in coordinate form, I have 7 that goes to negative 17. I have negative 6 that goes to negative 17. And I have negative 13 that goes to negative 17. I don't care about a repeating y value. But since the x values do not repeat, this is a function. Yes, this one is a function. This one is not. All right, so let's move on. Now, if we have a graph, we have to determine whether it's a function. And there's something that will tell us whether it's a function or not. By the way, somebody guess, is this a function or not? Yes or no? Just type it in the chat box. Is this a function? Let's just take a guess. I'm not worried about if you're right or wrong. I'm seeing who's awake. Yes, yes, yes. No, no. Ooh, I got a couple yeses, a couple no's. All right, watch this. This is the graph. Look at this coordinate. That, on the graph, there's a whole bunch of dots, right? Let's look at this coordinate. if I were going to write that coordinate, it would be 5, 4. X is 5, right? And Y is 4. 5 and 4. Look at this coordinate right here. X is 5. Y is -4. I have a repeating, on my graph, I have a repeating X. This is not a function because it has a repeating X value. Another way of looking at this, we call it the vertical line test. If vertical line touches graph more than once, it's not a function. Watch this. I draw a vertical line right here. It's touching here, it's touching here, it's touching there. No, not a function. If a vertical line, I mean, you can't draw the vertical line over here. You got to try to touch more than one spot. So if I try, I go vertical line straight up and down. If I draw a vertical line, do you see how it touches more than one spot? So it's not a function. So you can draw a vertical line. If it touches more than one spot anywhere on the graph, it's not a function. If you look at this graph, I'm going to draw a vertical line if I can. It's not easy. I need a ruler. Do you see it only touches the graph here? If I draw another vertical line, if I drew a vertical line instead of a squiggly line, let's see if I can draw a vertical line there. You see how it only touches one spot? Here, I'm going to draw a vertical line, and if you go here, it touches only one spot. So any vertical line will only touch one spot on the graph. So yes, this is a function. So the vertical line test will tell you if you have a function or not. Is this a function? Yes or no? Type it in for me. And I see a couple people writing no, because I can draw a vertical line and it's touching more than one spot. No, not a function. Now I'm going to do domain and range for this problem. Or wait, is it say, yeah, domain and range. So we know what domain means. We haven't talked about range yet. Domain is what can X values be? What can X values be? Range are what can Y values be? So the domain of this function, we always look, it's not a coordinate, it's a interval. So we talked about interval notation the other day. So it's not a coordinate, it's an interval. And we always look at the lowest X value and then the highest X value. So if you look at this graph, you know, when I draw a line here, there's no graph over here. There's no negative right here. There's no graph. So do you see X -10? There is no graph. So -10 is not part of my domain. The farthest left is right here. The farthest left is that spot right there. It's hard to see. I don't know. I think they meant to have it touch this, but I'm saying it's right here. So I'm calling it 1/2. Do you see this? Wait, let's this is 10. Oh, they go by twos. 8, 6, 4, 2, 1. So I'm calling it the domain. The smallest x value in this graph is 1. You see the far left of this graph right here. I'm calling it 1. That's 2, 4, 6, 8, 10. The largest x value, do you see this goes on forever? So way over here, it goes on even though it's going down and on. The largest x value is infinity. Is everybody okay? When you look at the graph, the x values are the farthest left, the lowest value. Maybe I should put the farthest left on my graph, and then the highest value is the farthest right. Since these things have arrows, they go on forever. So they go on to infinity on the x axis here. They go on to infinity. So this is our domain. The smallest x value is 1. The largest x value is infinity. Now the range is the y values. The lowest y value and then the highest. So if you look at this, do you see how this goes down? And since it's an arrow, it's going down. If you look at -10, there is a graph because it goes down. At -20, there is a graph because the graph goes there. So the y values in this case, if you look, this is going down slowly, but it is going down. So that's going down to -infinity. Maybe I should put it up here. So the range, I'm getting a little messy. The range, the smallest y value is -infinity. Do you see -10, -20? This graph is going down, 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 and to the right. It's going down and to the right. And it's going down forever. So that means it's going down to -infinity. Same way with the highest graph, here's 10, there's higher than that, here's 16, the y value, it's higher than that. This goes up forever. So way up here at infinity, if you come over to the right, you'll touch the graph. So the range is -infinity to +infinity because this graph goes up and down forever. So for this graph, to clean it up a little bit, domain started at 1 and goes to infinity, starts here at 1 and goes to infinity. You see the graph just goes to infinity. The range, the lowest, this thing goes down forever, so it goes to -infinity and it goes up forever. The highest graph is +infinity. This is the domain and range for this function. Oh, for this function. It's not a function. We already said it's not a function. I just wanted to go over the domain and range. Normally on the homework, if it's not a function, you don't have to do the domain and range, I think. All right, let's look at number 6. So these don't have arrows. They don't go on forever. They stop. So domain. Can somebody type in, what is the smallest x value you see on this graph? What is the smallest x value? The farthest left this graph goes. No, you have to put parentheses for domain and range, Amanda. It's like interval. Yes, the smallest x value is -3. Do you see? the graph doesn't have no graph at -4 or -5. The smallest x value is -3. But oh wait, this brings up a good point. Thank you. That brings up a good point. You're absolutely right, Amanda. I'm going to go back to that last question. Now look at this. This is a filled in circle. So the domain for this graph, it's touching. A filled in circle means it's touching -3. And then the largest x value, if you look right here, the largest x value is 0. There's no 1s, 2s, 3s. The largest x value is 0, and it is touching 0. This graph here is -1, 0. It is touching. So this is the domain from -3 to 0. It's touching both of those. Thank you very much, Amanda. The range. The lowest point of the graph is down here. Now, it's really hard to see, but it's not touching negative. Usually when you have that, it gets really close. It's hard to tell unless they tell you it's touching. It's really close to -5. There's nothing that tells you it's absolutely touching -5. It's really close. I'm kind of curious to see what the back of the book has. If they're using a bracket or parentheses, I would use a parentheses.
The back of the book has a bracket with the negative.
Okay, so they're expecting you. It's really, normally they put a dot here and they say, yes, you're touching -5 or something. Okay, so if you look at this, the parabola, it's a curved shape. It's hard to see, but it is. They're saying it's touching -5. Okay, the highest y value, here's y1, y2, y0. Do you see right there at y -1? And it is touching y -1. So that's my range. The lowest is right there at that tip, right on -5. The highest is right there at -1. Do you see there's no graph above or below those two lines? So yes, you do use brackets if it's touching, and I'm going to say for now on, all parabolas, all these curve shapes are going to touch whatever number we're looking at there. And so when we looked at this one, I'm going to say the back of the book says 0, but they just drew this wrong. Does the back of the book say 1 for this one or 0? I'm hoping it says 1 for domain. I don't know what remember we said 1 to infinity.
Yeah, it says infinity.
Yeah, but what does it say, 1 or does it say 0?
Yeah, it says 1.
Okay, so since it's a parabola, we're going to say it's touching 1. It's hard to see, but it's really close there, right there. So it's touching 1. And then the range, you can never touch infinity. So this is what the range looks like. Range always has parentheses because you can never touch infinity. So 1 has the bracket, but infinity always has the parentheses. Thanks. I don't know why they want us to do number 7. Because at number 7, we actually learn how to do this. We actually learn how to do this, I think tomorrow or the next day, which is kind of weird. How to graph this. I'm going to draw the picture for number 7 for now. Okay, I'm going to draw the picture. This is a parabola. We'll talk about that, I think, tomorrow. And plus 8 means the graph actually starts at 8. So this is what the graph looks like. It's a U-shaped graph that goes up. I should have did it in a different color so we see. There, this is what this graph looks like. Y equals x squared plus 8. And they're asking, oh, by the way, oh, I'll go back to number 6 again. But number 7, they're asking the domain and range of this. So if we look, this is really hard to visualize. You have to visualize. Parabolas are U-shaped graphs that go on forever. This graph is going up and to the left. It's hard to see. It's going up and to the left forever. And this graph is going up and to the right forever. So domain, since it's going, it's going up and it's going up and to the left. It's hard to see, but it's going up and to the left. That means it's going, the x-axis is domain. It's going all the way to negative infinity. And the x value, this is going up and over all the way to positive infinity. It's hard to see those U-shaped graphs, but they go up and they go up and to the right, and up and to the left forever. It's going up and up and up. So the domain is negative infinity, positive infinity. Now the range, the lowest part of the graph is 8. Do you see? That's the y value. The lowest part of the graph is 8, and it is touching 8. So we have to use a bracket. And the highest part, this thing goes all the way up to infinity. You can't touch infinity, so you use parentheses. So we'll actually learn how to graph these this week. I'm not sure when, maybe tomorrow, but maybe later on today. But I don't know how they expect you to give the domain and range for that without being able to graph it. And we haven't learned how to graph it yet. Now, domain and range for square roots are kind of simple, I think. So is it asking for domain and range or just domain? What is the domain and range? Okay, yes. Okay. So on this one, the domain of square roots, step 1, take inside and make it greater than or equal to 0. Step 2, solve for x. Step 3, graph it. Step 4, domain and range. So in this problem, we take the inside, just this inside, 2 plus x, and say it's greater than or equal to 0. Do you see step 1? We take the inside of the square root and say it's greater than 0. Step 2, solve for x. I just need to get the 2 to the other side by subtracting 2, subtracting 2. And x is greater than or equal to negative 2. 0 minus 2 is, that's my domain. But I'm going to graph it to help. Here's 0, here's negative 2. X is greater than or equal to negative 2. That's what the graph looks like. X is greater than or equal to number negative 2. So the domain, if we graph this, the far left is negative 2 in a bracket. The far right is infinity. That's the domain. Now, square root graphs, I'm going to show you what it looks like. A square root graph There's -2 for this one. Square root graphs look like this. They go up and to the right. They go up and to the right. So the range, unless there's something outside here, the range for everything with a square root graph like this, the range always starts. Do you see the lowest part of the graph will always be at 0? And then it's going up, 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 up to infinity. You see, there's no, you can't have the graph, square root graphs always look like this. They start at the point of here, -2, and then they go up and to the right. So let's try the next one. The domain of number 9 is 4x minus 5 is greater than or equal to 0. We have to just write the inside greater than or equal to 0 and then solve for x. I need to get the 5 and the 4 to the other side. The add and subtract comes first, so I'm going to add 5, add 5. All we're doing is solving for x here. And then divide by 4. Divide by 4. And x is greater than or equal to 5/4. If I were going to graph this on the x-axis, 5, this is 0. I'm going to put 5/4 here, 1 1/4. X is greater than or equal to that. So the domain, the left side is 5/4. The right side goes to infinity. The range, this is what the graph looks like. Starts at 5/4, goes up and to the right. So the range, the lowest y value is 0, should be a bracket, because it's touching 0 right there. And it goes all the way up, even though you can't see it, it's going up and to the right. Do you see it's going up and to the right? It goes up to infinity. There's the domain and range for number 9. Domain, what can the x values equal in? By the way, let's take a look. We just said the domain is 5/4 to infinity. What can the x values equal? So what if I said the domain, what if I said 0? Watch what happens when I put 0. Do you see how 5/4 is 1 1/4, 1.25. 0 is not part of the domain for this problem. If I put 0 in here, 4 times 0 is 0. 0 minus 5 is a -5. The square root of -5 on my calculator says error. You can't take the square root of a negative number. You see, that's why 0 is not part of the domain. The first number that doesn't give me an error on my calculator is 5/4. That's the first number. If I plug 1 in here, 4 minus 5 is -1. I get an error on my calculator. 5/4 is the first number that doesn't give me an error. Domain, what can the x value equal? And I get an answer. Okay, this is a linear equation. Let's graph this really quick. Somebody yell out an x value, any x value. Just yell out a number.
3.
3. If I plug a 3 into this for the x, 2 times 3 is 6. 6 plus 11 is 17. That's a coordinate. 3, 17. Do you see there's a dot at 317? Somebody yell out another number.
4.
4. Let's do something easy like 0. Come on, people. But 4 is fine. I don't want to get too crazy. Yeah, I know. Let's do 4 then. 2 times 4 is 8. 8 plus 11 is 19. Do you see? If I plug 4 into this function, I get 19. 4 and 19 would be right here. So if I connect the dots, if I connect these dots, this is my graph. It's a straight line. It's a linear equation. Okay. The domain of all linear equations, look at this. This graph goes down and to the left. So it goes, the smallest x value, far left, it goes down and to the left. So the domain is going to be negative infinity. Do you see it goes to the left? And this goes up and to the right. So even though it's going up, it's still moving to the right. So it eventually, way up top, it's going to get to positive infinity. The range for linear equations, also the lowest part, this graph is going down to negative infinity, and it's going up to positive infinity. Domain and range for linear equations are usually negative infinity to infinity. The domain and the range. The y's go on forever, and the x's go on forever, and then the y's up and down go on forever. Okay, number 11 might be the only tricky part. Well, number 11 and 12. Let's see how these do. So we did domains for parabolas, the U shape, when you have an x square in the graph. We did the linear functions, we did square root functions. This is a rational function. Remember, rational, that means a fraction. Where we have an x on the bottom of a fraction. Rational functions have an x value on the bottom. Remember, on your calculator, 5 divided by 0 gives you an error. So the only thing you have to worry about for the domain of this function is the bottom cannot equal 0. So for rational functions, you take the bottom and say it cannot equal 0. The bottom cannot equal 0. We don't care about the top. And then we solve. Just get the 6 to the other side. It's a minus 6, so I'm going to add 6. And I get x cannot equal 6. That's the domain. X can equal everything else. It cannot equal 6. And I think your book will let you write it down this way. This is called set builder notation with the x and the line through it. X cannot equal 6. This is one way of writing it. Another way, if we graph it, here's 0, here's 6. X cannot equal 6. In other words, that's 6. That means there's a hole at 6. X cannot equal 6. X can equal everything else. Do you see? Everything else. But it cannot equal 6. So another way of writing that is the far left is negative infinity. Then it goes all the way to 6, but it doesn't touch it, because if it touches it, it equals. It cannot equal. But then we jump over on the other side of 6, and we go all the way to positive infinity. And normally when we write it down like this, we put a union symbol, this U thing. It's called a union symbol. This is how we write the domain for rational functions like this. So this is called the interval notation. And this is called set builder, depending on how they want you to write it. I think this is okay. I think they're going to want it this way, but this is another way of writing it. Anybody at the back of the book can say which one is correct? I like the one on the left. It's so much easier.
Back of the book has the one on the right.
Oh, on the right. So interval notation. Okay. But they both mean the same thing. They both mean the same thing. Do you see? X cannot equal 6. That means X equals everything else. This means X cannot equal 6. It equals everything else. It gets to 6, and then it jumps over 6 and starts up again. It does not equal because there's no brackets on the 6. There's no brackets on the 6. Gets really close to 6 on one side, jumps over it, and then really close to it on the other side, but it doesn't touch it, and then moves on. And we're going to do the same. So this is the way they do it in the back of the book. Just have this written down in case you're doing that in the homework also. Number 12. So it's a rational function. All you do is take the bottom, 17 minus x, and say it cannot equal 0. The bottom cannot equal 0. And then solve for x. Get the 17 over by subtracting 17, by subtracting 17. I get negative x cannot equal negative 17. And then I have to get rid of the negative sign, and you can divide or multiply by a negative 1. Divide by a negative 1. Negative divided by negative is a positive. Negative divided by negative here is a positive. So the domain is x cannot equal 17. If you look at a graph, here's 0, here's 17. The graph can be everything except 17. So it goes from negative infinity to 17, gets really close to 17, jumps over it. On the other side of 17, it goes all the way to infinity. It just doesn't touch 17. So this is the way called interval notation. And you can see if you put 17 in here, 17 minus 17 is 0. 17 over 0 on your calculator says error. It's undefined. It can equal anything else. Anything else I plug in there will give me some type of answer. The only thing that won't give me an answer is 17. And I'm not worried about the domain on these. The range on these, until we graph things later on. I should have never did the range on those other ones. All right, until we start graphing these later on. All right, so we're still dealing with functions, and a lot of people have, how many problems do we have here? Oh, good Lord. These are actually fun. I don't know about fun, but they're different. I think they're easy, but we have to understand what the symbology means here. It's really important to understand what we're talking about here. Don't forget, this f of x really means y, okay? That's y equals. So it's, that's y equals. So I want everybody to understand f of x equals y. This is a holding spot for x. Holding spot. There's no math happening in that holding spot. In this holding spot, there's no math happening there. That just tells you what x equals. Tells you what x equals. So down here, they said x equals -1. Do you see this function? It says x equals -1. That little spot in there is telling you what x equals. X equals -1. So we're going to rewrite the function and plug -1 into the x. Do you see? There's our x value. We're plugging -1 in there. And I want to put it in a calculator exactly as I see it now. So plug it into your calculator exactly as you see it. That's a -1. That's a -1. When you plug that into the calculator, you get -4. I hope. So in other words, when x is -1, y is -4. Do you see? This is y. That's the x, and that's the y value. When x is -1, y equals -4. Wait, is that right? Yes. Yes. Okay, let's plug x into the function now, 0. Here, the same function up here. This is the function. And we're going to plug it in there, you just have x squared minus 2x minus 7. This time, we're plugging 0 into the function. Everywhere you see an x, we're plugging a 0. And when you do that math, you get 7. 0 squared minus 2 times 0 is 0 minus 7. That's it. So we're plugging that number into all the x values of the function.
So it would be -7, right?
Yes. Oh, -7. Thank you. There's our answer, -7. That's 0, and that's 0. So the answer is -7. Thank you. So what's the answer for C? And I really recommend when you're typing this in your calculator, use the parentheses like I did, and then plug the correct number in. If you don't use the parentheses, you often get the problem wrong. And somebody told me they got 1. And the answer is 1. There's another one. So we got a confirmation. So f of 4 equals 1. Do you see? When x is 4, y equals 1. All right. This is a little bit harder. Oh, man, I don't want to do this next one. Please don't make me do it. You got to do it because you're going to have this on the homework, and you're definitely going to have this on the test. 13D. Look at D. Look here. Look at A, B, and C. Do you see on these, they tell you x is this, x is this, x is this. Here, x, we're trying to find out what x equals. What does -4 represent? Can somebody help me? What does -4 represent?
Y.
Yes. F of x equals y. This is the x value. This is the y value. That is y value. So once again, here's our function. We already said this is the same thing as y. F of x is the same thing as y. So we're putting the y value, -4, up there. I mean, here, watch what we're going to do. This time, we're not plugging anything into x. We're using -4 goes into the y value. That's the y value. We're changing f of x to y. We're just interchanging them. Okay, and we have to solve for x. So here, plug in y, then solve for x. And you got to go through your whole solving techniques. When you have an x square, you got to get all the numbers on one side, everything on one side. So I'm going to add 4. I get 0 equals x squared minus 2x. Negative 7 plus 4 is a negative 3. And now if I have x squared minus 2x minus 3 and it equals 0 to find x, I have to factor this thing. Oh no, factor. There's only one factor, 1 and 3. How do I get a negative 2? A negative 3 and a plus 1. X plus 1, x minus 3. Then you set it equal to 0. X plus 1 equals 0, or x minus 3 equals 0. So we've done this on previous tests, or even on this test coming up. No, on previous tests. Then get the 1 to the other side by subtracting 1 to both sides. And x equals negative 1. That's one answer. Get the 3 to the other side by adding 3, and x equals 3. So we have two answers for this function. X equals negative 1 and x equals 3. So we have two x values where y equals negative 4. So we have two separate x values where y equals negative 4. That's why I said that's a tough one, because you have to plug it in to the original function. We plugged it into the y value, and then you got to take it over. You get this, factor it. We factored it and got this. Use the 0 multiplication rule. X plus 1 equals 0, x minus 3 equals 0. Solve for x, and we have two answers. So D is a tough one, but when you're on the homework, pay particular attention to it, the steps, because there's definitely one of those on the test. These aren't too bad. You plug it in and put it in your calculator, you're good to go. If you plug it in your calculator correctly. All right. So this next doesn't give us an equation, but they give us this function. And in this function, we just have a whole bunch of coordinates, xy, 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 xy. So we just have a whole bunch of coordinates. So what does this 3 right here represent? What does the 3 represent right here? What letter?
X.
It's the x value. Up here in the function, x equals 3 is right here. So the answer to x equals 3 is y equals 0. Do you see? We're just using the coordinates. When x is 3, y is 0. That coordinate is 0. So what do you get when x is 5? What's the answer? Anybody?
Y equals negative 2.
Yes, here's x5. The answer is y is negative 2. x4. It's not up here, so there's no solution. There's no answer. It's not part of the domain. The domain is all the x values, and this function lists everything, all the coordinates. There's only 4 points on that graph, and there's no x value 4, so there's no answer. What about this one? Remember, what does the 5 represent again? What letter?
Y.
The y value. So up here in our function, the y value is 5. What does the x value equal?
0.
Yes, this one. So that's an easier one though. And so the x value, x equals 0 for this one. Do you see? When y is 5, the x value is 0. So it's important to understand these are the x values, and then what's by itself, not in the parentheses, is the y value. All right. So these are just different ways of showing different functions. Okay, so we have to use this graph, and I think I'm going to make this smaller so I get a bigger picture in here. Oh no, how many? Yeah, this is it. So here they just give us this picture, and find f negative 2. So when it says find f negative 2, what are we looking for?
The y value.
Yes, thank you, because a lot of people don't know. Remember, what's inside the parentheses is the x value. We're looking for the y. So at f negative 2, here's the x value, right? This is the x value of negative 2. Right here is x negative 2. We have to go up or down to find our y. That graph right there has a negative 2 x value. The y value for that point on the graph, do you see negative 2? The y value is negative 2 also. Oh, positive 2, I'm sorry. Does everybody see that? Let me erase that. If the x value is negative 2, that negative 2 is, this is where the x value is negative 2. But you have to go to find the y value for negative 2, and it's right here. The x value is negative 2. The y value on the y-axis is 2. When the x value is 5, here's 5. Go up or down till you hit the graph right here. The y value is also 2. Right there at 2. Now, the next one. This one tells us you have a y value, you have to find the x value for it. That's a question mark. So when y is 6, here's y 6. Go right or left till you find an x value. Nope, right, you can't, there's nothing there. Oh, right here. There's that's a y6. You see the coordinate for this is y6. What's the x value that I put in this? If y is 6, what is the x value?
Negative 6.
Yes, right down there.
It's touching.
Negative 6. Do you see that coordinate? This dot is x value negative 6, y value 6. So the x value equals negative 6 when y equals 6. And they're asking for the domain and range of this function, so I'm going to give that to you on the right-hand side. Domain, the smallest x value is right here, negative 6, and it's touching negative 6 because there's a filled-in circle. And the largest x value is positive 6, and it's touching. The lowest range, remember, domain is right or left. Range is up or down. The lowest y value is right here. This is a y of 0, right? Y negative 1, negative 2. Y is 0 is the lowest. The highest y value is 6. So that's the domain and range. The domain is the farthest left, the farthest right of our graph. From right here and right here. The range is the lowest part of the graph and the highest part of the graph. All righty. So we have some more. If x is 5, here's 5. Find out what the y value is on the graph. Or here's 5. If I go straight up, right there, at this point, x is 5, y is 10. When x is -3, here's -3 going up or down. Oh, we have to go down right there. It's hard to see, but I think it's -1/2. Wait, maybe, no, yeah, it's not at 1, -1. It looks like at -1/2. So that's what do you see how low right at, that's -3. The coordinate is -3 on the x, but the y value looks like -1/2. It doesn't quite go to -1.
The first one, it's looking like it's 11, not 10.
Oh, maybe, yeah, that's just
Yeah,
because
it's 11, I think.
that's
Yeah, it
just
looks
because
like
I'm
11.
blind. Let's see, 5 stops here. Oh, you're right. And there, it goes to 11. Thank you. Yeah, you guys got to be, you got to see, I made it smaller so I can get the whole picture in here. Now I can't see. Okay, so what happens now in the next one when y is 5? What are the x value? I need to find x. Y is 5 right here. This is 5. So I'm looking for an x value, nothing. Oh, right here is an x value, the graph. And if,
2, it's showing 2.
okay, x value 2. So when y is 5, x is 2. Do you see? You can put it, you can write it like this: x is 2, y is 5. Either way. And I'm going to give you a second. Write down the domain and range for this. Let's see if you guys can get the domain and range. Anybody want to type it in? Try to type it in. Domain and range. I'll give you a second to try it out, and then I'll write it down. Domain and range. So, anybody want to try to type it in chat box? I don't know, anybody dares. Because we'll laugh at you if you get it wrong. Okay, so it looks like the domain. Do you see the smallest x value? The farthest right the graph goes is right there at -6, and it's touching because that filled in circle. And the farthest to the right it goes is right there at +6. That looks good. Perfect. Now the range, you see the lowest value is down there. Be careful, Alma. It's -1/2. It's below the 0. Do you see? So it's at -1/2, and then it goes all the way up. Looks like the 13, and it's touching. Good. 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 That's the domain and that's the range. Remember, range is the lowest point and the highest point of the graph. And the domain is the farthest left and the farthest right. Okay. How many were there here again? Oh, okay, 3 more. This is not too bad. These aren't too bad either. Number 17, 18, and 19. So it says determine where the graph is increasing and decreasing. Look, this arrow, but it means it's going over forever, right? What the arrow means is going up and to the right forever. Same way this one, it's going down and to the left forever. It's important that we understand that, those arrows. So the domain, oh wait, it says where is the graph increasing and where is the graph decreasing and where is it constant? Well, increasing is always from left to right. For all of these, increasing is you're always moving your pencil from left to right when you're talking about increasing function. So if I look at this from left to right, I'm moving left to right. Is the graph going up or down?
Up.
Yeah, do you see? It's going up the whole time. So we're not talking about domain of intervals of the domain. So it's increasing. This graph is increasing from negative infinity to positive infinity in the domain part. When we say domain, we're talking about the x values. When we talk increasing or decreasing, I'm sorry, we talk about negative infinity, positive, we're talking about the whole domain. From negative infinity to positive infinity, the whole number line. If you look here, the graph never goes down. It's always going up. Here it goes up a little sharper, but it's still going up. It never goes down. So it's increasing here. It's not decreasing anywhere. It's not constant anywhere. It's increasing the whole time, and that's it. The graph is increasing the entire time. Now, if we look here, and once again, I'm going to draw this line. This arrow means it goes on and up forever, goes up and ever. If you look at this from left to right, you got to move from left to right. The graph is going down. The graph is going down. And it stops going down right here. So it's decreasing. Going down means decreasing, if I can write, decreasing, and we're looking at just the x-axis, you know, negative infinity or positive infinity and negative infinity here. So it's from negative infinity, the graph is going down, 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 and it stops going down right there at -3. By the way, at -3, it changes to constant. So you can't put a bracket. For increasing and decreasing, you cannot put brackets. You have to put parentheses because at -3, it goes from increasing to constant. Do you see? It's at constant now. So it's constant from -3 to wherever this is, 3. And then it's increasing from 3 to infinity. And you never put brackets for increasing or decreasing function because there's those changing points. It's not increasing or decreasing, it's changing. So from negative infinity, that's negative infinity, to -3, it's decreasing. Then from -3 to +3, it's constant. It's a flat line. Constant is a horizontal line. Increasing is going up. Decreasing is going down from left to right. You always go from left to right on these graphs. Number 19. By the way, it's hard to visualize this, but this graph is going up and it's going to the left. I mean, the higher you go, it's moving to the left. I know I'm drawing it curved, but it's a straight line. It's moving to the left and it's going up. Same way with this one. It's moving up and to the left. So if you look at this graph, from left to right, the graph is decreasing from negative infinity, right? Negative infinity is over here, and it stops decreasing at this point right here. I think that's -1. Decreasing. And then it's increasing from -1 all the way, it's increasing from -1 all the way to infinity. And there's no constant because there's no horizontal line there. It's just decreasing, then it's increasing. And -1 is that turning point for it. And that is 2.3. Stop recording.